All right, folks, we're going to go ahead and get started. Welcome to the Research Vessel Safety Standards Appendix A and B training. I'm Megan Corcoran. I'm with the UNOL's office. I'm the crewing support manager, and you may wonder why does somebody that does crewing want to have this training, but when I was the port captain for University of Washington, I wanted this training very badly. And so it's wanted throughout the fleet, so that's lovely. And I also saw this as a potential retention thing for crew within our fleet. So it's really nice to see so many crew members in our fleet here as well, and also outside of our fleet. A few things to go over. There are name tags for everyone, should be for everybody in the back. And then there's lanyards there. There's also a sign-up sheet. Please mark yourself as here on that sign-up sheet. I need it in order to justify why we spent so much money on food. So please sign that. Cell phones, if you have them with you, which I'm sure you do, please make sure they're on vibrate. Those folks that are online, just make sure that you're muted at all times. If you would like to answer a question, I'll be looking at the screen to see who has their hand up. So online, those folks that are online, please have your hand up if you have a question. If anybody needs an agenda, there should be an agenda at each seat for the most part. If you need one, I have more up here. Lunch will be served both days, so don't worry about that. We'll have it all ready for you. And then we would like to go around the room and just do brief introductions so we know who's here. Unfortunately, there's so many people online that we can't do it online, but for those that are here in the room, we'd like to start. So we'll go ahead and start over in this corner.
University of New Hampshire, Vessel Captain.
Yeah, Franny Lux, University of New Hampshire, Marine Captain.
Dave Reynolds, University of New Hampshire, Facility Manager. Ted Colbert, JMS. Stein, Chris Alminetti, URI, Captain on the Endeavor. Michael, Endeavor, Nate. Paco, Logistics. Vessel, U.S. Coast Guard Service Force. Beverly, Service Forces Logistics. The University of
Maritime.
Alex Peterson. Brian Guest with Oceanographic and Matt. Care of the RVSS. Authority. Friday, she's ringside. Josh Singer, Lamont Doherty, Ford Doherty, like I said. Valdo, University of Alaska. Levine, University of Alaska. Nelson Greedy. Script. John Center from the meetings. University of calendar ship operations as well.
Okay, thank you. And I think we missed you.
John Hunt, University of New Hampshire.
Thank you. And then most importantly, welcome everyone. I'm so glad to see so many faces here. Wi-Fi. I was trying to write it up on the board, but I couldn't find a marker. So, Wi-Fi, the network is who we guess. If everyone wants to write this down, if you want the password, it is inlet, all lowercase, so INLET, 28511. So inlet 28511. Okay, I think that's all the logistical things. So first up, we have Ted Colburn.
See if this works. Can you hear me? Yeah. Hey, good. I never worn one of these before, believe it or not. I'm from JMS, and I'll be talking a little bit through the steel cables and wire ropes. I want to welcome the people online. Just offhand, one of the persons supposed to be online is Rich Finley, who was at the beginning of when Appendix A was starting. So we can save some questions for him for the break if we want to know some of the original details from early 2000s. Let's see. Where I'm going to see it best. Thank you. Yep. Appendix A was to establish safe and effective operating environments beyond the traditional shoreside aspects of using wires and cables. Typically, if you operated wires and cables at shoreside facilities, we would never be able to do oceanography. Keeping things safe and to bring back equipment. Some of the first slides are mainly in there for background. Limits the amount of, he asked for help. Can you change it? Can we change the contrast on this? May not be able to. That's a little better. Thank you. Basically, Appendix A works on factor of safety. We'll talk about that later. It doesn't apply where other things apply, and it assumes that things are being operated properly in accordance with their manufacturer's recommendations. Appendix A includes administrative and operational and maintenance actions. Terminology, we'll be talking terminology as I go through the presentation. There are acronyms at the end of the RVSS and definitions in the beginning of Appendix A, also Appendix B, and some of those definitions go between the two. Appendix A is for ropes, wire ropes, synthetic ropes, and cables. Appendix B is for the overboard handling systems for the vessels. Safe working tension, sometimes referred to as safe working load or working load limit. Safe working tension is the terminology used here. It seems very viable, so we'll use it whenever we can. And a tension member is the term for the wire rope or cable or synthetic rope that goes over the side. Rope, there's some aspects here. Typically, it's made of wire, synthetic, fabric. It does not have conductors inside. Just offhand, the 3x19 is considered a torque balanced line, which basically, if you hang something from it, it should not rotate, where other types of lays on the rope will rotate. Cable has a conductor or some sort of communication system in it. Tested breaking load is the amount of tension it takes or load it takes to part the cable or wire rope. It may have either a fixed end or testing or free end testing. If it's a free end testing, it would have, or if it's free end tested, it would have a swivel or ability to rotate at one end. The nominal breaking load is the advertised load that the wire rope or cable is given by its manufacturer. So if you go down the store and buy a piece of line, they're going to say how much load can they say it takes. That's the nominal breaking load. It may be high or may be low. The assigned breaking load is what we use for Appendix A. It's the lesser of the tested breaking load or the assigned breaking load. And I mentioned the free end and free to rotate and fixed ends. Most of the systems or the testing, and if I understand correctly, is done providing information for fixed ends, but you may see one or the other. A fixed end operation would be something like the mock mast. You put it over the stern, and it doesn't rotate. Another one would be a trawl net. Generally, the fixed ends have a higher breaking load. A free end would be a CTD going over the side. As it goes down, it's free to rotate. Factor of safety. This represents the ability to determine what you allow your cable or wire rope to operate at. Factor of safeties, this Appendix A groups them into 4 different groups. 5 or greater, which is typically the shore side aspect of using wires and cables. Then 2 others below that. The 2 to 1.5 is for wire rope only. Cables operating at the 2 to 2.5 are likely to get permanent damage if they're operated in that range. Safe working tension. This is the allowable amount that you'd be able to operate. It's based on the applied breaking load to the factor of safety. It would be different potentially for fixed end and free to rotate ends. We're going to go through a little more detail here. The shivs, rollers, tension monitoring, and alarms control what the limitations are you can operate at your factor of safety. We'll go through the shivs first. One of the important things on the shivs is they're large enough. So you have the diameter, the root diameter of the shiv. The size of the shiv is determined by the makeup of the cable or the wire rope. And for factors of safety of 5 and over, it's whatever you can provide, best practical you can provide. This brings in more or less the historical vessels that are operating based on equipment they already have on board. If you're operating below a factor of 5, then it's determined by the diameter of the wire or cable and the diameter of the the wire that makes up the strand. Or in the case of cables, it's the outside armor. Why are those important? As you increase the sheave diameter, the lifespan of the cable or wire rope gets greater. That kind of makes sense. In this case, just an old example, if you increase the diameter by 20%, you increase the service life by a third. So it's good for service life. It also increases the amount of tension it would take to break the cable or wire rope. For UNOLs, supplied cables and wire ropes, these are the limitations on the right column that provide the minimum diameter. The red indicates the controlling factor. And just offhand, for 322, you notice it's 15 inches. And many winches made before Appendix A was put in place did not have sheaves for 15 inches. Just offhand, if you look up the manufacturer's recommendation for 681 cable, it indicates it would like to have a 48-inch sheave diameter. So if you're thinking about purchasing equipment to operate the 681, you want to get together and talk with the wire pool and so forth in the future. Even though now the requirement is less, it's good to listen to manufacturer's recommendations where possible. Some of the factors besides the diameter is going to be the groove width and the amount of curvature to the radius itself. You don't want the radius too flat, or you don't want it too tight. If you get it too tight, there's some pinching and binding potential, and you want it to be able to support and adjust itself to the curvature. Grooves too large will allow that cable to become elliptical, deform the cable as it goes around the sheave. It works that cable, creates a situation where some strands are stretched more than others, and some may go beyond their elastic limit. Cables, sheaves as they get worked, get smaller on their groove. So you want to pay attention to the shape of the groove, particularly synthetic sheaves, but others too. And some reasons for that, to be cautious, is if you're installing new cables, your new cable may be larger than your old cable. It can also, if you're end for ending the cable, you may find the end that was near the drum is larger than the groove. And also, if you're planning deep casts that you're not used to doing, also take a look at that too. The sheave radius is identified right on the UNOLS wire database. So Rick can keep us informed on that one. Now, if you want to check it, a good way of doing it is with the groove gauge. And this is the picture of the one that the wire pool created a few years ago and sent pretty much to all the academic research vessels and recorded on the next sheet for reference the minimum and the maximum sizes and wire ropes and then cables. If you don't have the groove gauge, fitter drill bits, you can't get it just the right size, but they are a useful tool in case you want to take a look and get a feeling for how does your groove go, particularly if you're changing out your wires and cables. Up until this last year, if you were trying to operate 9/16 wire rope on grooves for 680, you weren't allowed to do it except at basically a factor of 5, which doesn't do much at all. Based on a change this past June, you can now operate the 9/16, which is a good change, on a SHIV that was grooved for 680, 681. There are several SHIVs in the fleet and also traction winches in the fleet where you can actually change the grooves, which is a tremendous thing to do if you're doing it on a traction winch, so you can adapt the 9/16. That, luckily, based on a change in June, has eliminated a lot of the difficulties. Rollers. Rollers are tough on cables and wire ropes if they're loaded. So the old rollers that have been around for a long time on older equipment create a situation where typically they need to be operated at 5.0 or greater. There are exceptions, but most of them are smaller. But if you want to use a roller or upgrade to a roller, it should have the same requirement for diameter as a SHIV. Now, it can't perform as well as a SHIV because still on a roller, if it's loaded, the cable or wire rope becomes elliptical. So if you're using rollers, you want to minimize the wrap angle. Here's a picture of one for one of the vessels was changed out. Another picture in a moment. There's another type of aspect of the rollers, though. Those rollers that aren't under load, if the wire rope or cable turns as it goes around the roller, it puts pressure on the roller, then you have to abide by the diameter requirements for SHIVs. But there are also guide rollers, capture rollers, sense rollers. This shows a sense roller on a level wind, where basically all the roller does is try and tell where to wrap on the level wind on the winch. The cables don't bend around them. This is one from the Oceanus with the upgraded rollers. Makes quite a big roller. Also, cables and wire ropes should not allow contact with other surfaces. I'll see if I can get here you see at the bottom of those two rollers, the cable is resting or running on the framework. And another one. This is obviously not good and not approved under Appendix A. Also, your line wire rope should come directly off the SHIV where possible. Depending on the design of the SHIV, and Marquis has their SHIVs for the most part designed to allow for a 1.5 degree off-center aspect of it. Some SHIVs don't have any. So you want to look at the design. Here's one recent view of a wire leading off the side of a SHIV. This is tough on the SHIV. This is old equipment. I'm sure it's going to get replaced. Maybe it has been replaced by now. But that you can see looks more than 1.5 degrees, and the SHIV wasn't necessarily designed for it. Here's another one where the wire rope is coming off the side. Too much angle. Moving into tension monitoring and alarms. If you're operating at a factor of safety of 5, you don't have to have tension monitoring. It's nice to have. It avoids some other aspects. But if you're operating at less than a factor of safety of 5, tension monitoring is required. But when you're operating less than 5, your other option essentially is to calculate a estimated maximum tension based on what you have in the water and what depth and so forth. 4 factors, example is provided in Appendix A. Static loads, those are the weights and so forth. The quasi-static loads, which are drag, a little hard to calculate, but you can do it hydrodynamics. Dynamic loads, the effective heave on it, and transient loads to pull-out forces. So the example here provided in the appendix is for a bottom grab, and the calculations are based on those 4 factors, as I mentioned before. I've only seen a couple vessels. I'll use the Barnes as the first one where they had a table set up and they pre-calculated all the estimated max tensions for their operations and posted it in the lab. So once you get it done, you can, stay with it. It may change with depth, of course, but there is a way of calculating it. If you can gather the information from another source, that's also viable. At less than 5 and down to 2.5, your tensiometer systems need to operate at 3 hertz, which isn't much, but it's enough to give you indications of change. And you need to be able to log the tension of the same. Here's an example of the tension monitoring, the basic one, but it's not terribly basic. Wire out, speed, and tension in pounds. Also, you see in the fleet, particularly some of the larger vessels, the tension monitoring system needs to be available for the operator, but also it's very handy to have it on the working deck available to others too. So this is one of the examples from the ship that has it as a board, and this one I believe is in a staging bay. Now, when you go to 1.5 to 2.5, your tension monitoring speeds up. 10 hertz for the display. You really won't see that, but it's what the display requires. And 20 hertz for the frequency of recording. And at 20 hertz, you should be able to see most dynamic systems if you have to go back and take a look at that data. Also required is the capability to have a tension trending graph, a time series. And here's an example of one at the bottom. This system also recorded the max tension during the deployment. Here's another one which shows a different series. So there's a whole variety in the fleet. Now the system must be recalibrated no more than every 6 months. So you want your system to be accurate, and needs to be also maintained. You want to only calibrate it every 6 months. An important factor is what's happening during the 6 months. Is it staying within its tolerance limits or not? And depending on the factor of safety, at the higher ends of factor of safety, you should be down to 3% with those error bounds. The lower ends of loading, and the either 3% or 4%, depending on which section you are. This means that you need to look at it over time and not just count on the calibrations periodically, because you don't know what's necessarily happened. So it requires taking some data in between, and also particularly the data at the recalibration point to see if you're staying in calibration. This seems to be one of the areas which, when I go on the vessels, needs to be developed more on the vessels. Alarms. As you approach a alarm setting, the concept is that the system will alarm you that you're getting close to your factor of safety limitation. And one of the other factors it says in here, the alarms must be continuously, have the capability of continuously, alarm conditions must be monitored recorded, logged. Okay, sorry. And we'll move into safety and some other factors now. We're moving rather quickly, so I hope, are there any questions so far? Thank you. Safety is critical. The factor of safety of 5, basically good practices. When you move into lower factors, it requires more. No matter what factor you are, safe working tensions should be posted at the operator station, and e-stops should be available at all the stations, and that's an Appendix B recommendation. Aaron will talk about that later. Going to less than 5, creating danger zones, painting them on, marking them, putting them into your briefings to your science personnel. To the greatest extent you can, keep unnecessary people out of your danger zones. Here you have some lines going back to the A-frame. Some lines for the overboarding system for the CTD. Here that someone's amplified the safety line with the PPE. I think that's the Armstrong. More safety zone information there. Also, to barrier off or mark with warning signs the areas. You'll have people on board that aren't familiar with it and may forget about the briefing beforehand. So create your barriers, various ways of doing it. This was a good one right here. Another one, eliminate the access without somebody consciously being able to step over, step around, or get through another different area. On this one, this is the Armstrong. They've buried it off with a line and a sign, the area of the 2 above deck winches. And they're looking on here to improve this by making this a fixed railing in the future, so they don't have to put that sign up, and it makes it a little bit safer than having the line and the sign. When I go on board, I look to see if the ships are doing these. Another aspect is, where applicable, look at closing, securing, not necessarily locking, but closing the doors, putting signs there that where people could access the danger area. Sorry, the image isn't great on the photography. Jumping to the next one, this is why it's so great to have the diversity of people here, is extenuating circumstance. Things don't always go perfectly on ships. We all know that. There may be situations where your operation doesn't look like it's going to continue optimally. And so you want to look at creating, well, it could be situations to prevent loss of equipment, damage to the vessel, injury to personnel. You want to have a plan in place. I ask for these when I go on board, to look for a procedure and what's going to happen in case you have a situation that exceeds the limitations of the factor of safety or something else is not following Appendix A. When I go on board the ships, the ones that have come up are, the common ones are degrading weather situation, tension member in the propeller, payload package stuck to the bottom, winch failure, loss of ship's power, loss of payload package. It's good to dialogue. Don't just make one up and put it in an envelope. It's good to dialogue this with the captain, the mates, engineers as applicable, so that everybody gets aboard. When you make up a plan, you don't necessarily have or need to follow it exactly, but if you don't have a plan, look at alternatives, then my experience is that the first person with an idea gets it out there. It might not be the best idea. So you want to have ideas as to what you might do. A simple plan on, I believe this might have been the barns also. It's a startup place. Take a look at what the options are, what the alternatives are, and dialogue it within the ship. Also, it's all good to know that you have the right equipment on board. If you're thinking about buoying up the cable or wire rope, if you had to cut it, do you have something for a float on board? It would be could be a fender. If you're looking at cutting it, do you have one of the cutters that can go down the line? Chris Reiner's and Josh's cutters go down the wire rope and cut at the bottom. Do you have it on board? Is it ready to run? One ship, I understand, had a problem on one winch. They had drums the same. They actually shifted drums to be able to bring back the cable. If you have your newer electronics, is there a way to bring that wire back without having to hand over hand? So dialogue it around the ship and get some ideas. And I think it's an important factor that is, I look for when I go on board. Brake testing. Now, it used to be that if you had a factor of safety of 5, you didn't have to break the wire rope or cable. You just had to bring it up to safe working tension once every period of 2 years. Now, the newest update to Appendix A, and there haven't been many changes to Appendix A over the years, but this is one, is even if you're operating at factor of 5, get the wire rope or cable into brake testing. 2.5 and above should be tested every 2 years. And one thing true is a 10% decrease in the ABL, or testing braking strength for the most part, if it goes below NBL. You want to get it tested more often, but particularly anytime you see the ABL decreasing, take a good look at that wire rope or cable. Typically, the TBLs are 20 to 40% above the NBLs for most cables and wire ropes. Barbara can give us more. Is that good? If you're operating at the higher tensions, 1.5 to 2.5, they should be sent in every year. Now, you can also cut off line, wire rope, and retest too, if you need to. If you have that decrease in ABL, do some evaluations. Take a look at the running use log data. Take a look to see if there's any unique things. Take a look at the EQ data and contact the wire pool and get their assessment of the situation. Essentially, from what I've looked at, and my limitation is that if you start seeing much of your tension, your TBLs going down much, take a close look to see if you have to remove part of that cable or wire rope or replace it. Training records. At 5.0, the master or owner, owner, it says on the restriction, must deem the vessel, the operator, competent. In writing for all winch operators. Competent means that basically they've gone through and been evaluated and they have a necessary experience to operate the winch. For all factors of safety, if you have any sort of configuration change in your monitoring system, your hardware, then the training should be renewed. Similar to if you have a structural change in it, you also want to take a look in Appendix B to reevaluate the strength. If the factor of safety is less than 5, they need to be certified, a little different, certified competent. They have to have gone through a training system, and they need to have been trained on the winch, the handling apparatus, onboard system, and the monitoring system. In both cases, they should be renewed annually. And in this case, the master shall verify the certifications and designate the approved operators. Yeah, I think maybe it's good. We'll take a short break. We're running ahead. Thanks. Let's come back at 5 minutes off. Is that good? Good.
So for the 916, you said that the 916 to the 681, or just the 680 can use the same group?
You can, provided there's a little slight difference,
Okay.
but it's pretty minimal. If using it, the shiv has to be 27 inches in diameter.
Okay.
It's in the thing, but yes,
Okay.
basically yes.
Okay.
Unless you happen to be in that one little niche, then you talk to Rick.
Okay. And is that the same thing for like the traction winch? For,
Yes,
like, the group?
that's my interpret.
Hey,
Wow. Okay.
Let's chat with Rick on that interpret.
Okay.
Yeah.
And then
That's a big thing.
that's a huge thing. I mean, so with our CRVs, we're providing for each shift, we have group diameters for the traction winch as well as we have a right now
Yeah.
for the flagging block that goes for the
Yeah.
ocean
Just,
winch, we have a double group shift for the flagging block.
Neat.
Yeah.
as you're talking about what?
Potentially, I mean, that's what we're going to have at delivery, but potentially later on, if we don't need that, or the operator doesn't need that, that's what we're
Yeah.
Soon you can do
Oh.
in-house certification.
Yes, it's all in-house certification. We're supposed to sign off on everybody. Yeah.
I don't know. I mean,
Well, I'm sure you can email that question in if you'd like. All right, if you want, I'll do it.
yeah, I'd just like to know what costs. I mean, because obviously, if you bring somebody new on board, you're going to show them how to work the winch. Whether you're not going to just say this guy's ran winches before. He's got an AD ticket.
Yeah.
Check off. You're going to be like, this is our Dynacon winch. It's how you turn it on. Probably never seen it winch before. So
Yeah. I mean, we used to have certifications for new people on the Pelican. I don't think we've ever done it on the Point Sure, but yeah. I don't know if I heard that part, but I can ask that question.
That's what he said. Low level factor 5 is less than they had to be certified. And like I said, I know you can get a certification for Dynacon.
No.
Ain't no way you can operate that.
Certified. You talking about the operator, or are you talking about the whatever we're doing? Yeah.
Certified to run the winch.
Well,
Safety level less.
he may have misspoke. We need to look at the appendix. I haven't really studied them since I glanced over them when they redid them. I didn't see anything that surprised me, but we could relook at them.
Yeah. curious what, I mean, how you're approving somebody without certifying.
Yeah. So I just sent everyone an email, which Megan sent out at 8:30, 16 minutes ago. So we have some examples. I mean, if we ever wanted to amend these examples to match our vessels, we could probably do that too. But it's probably good reading materials. See, companies like Scripps, they have their own in-house engineers, which is Davis, Aaron Davis, and I know he does all their own, you know, he does all their in-house. I mean, they have a person that's all they do is worry about this stuff. So we don't have that person. Hopefully we'll get a person for the new vessel that this is one of their jobs. And, you know, they deal with all the wires and the tensions and they make sure we're all compliant.
Right. I was going to say, I mean, before the boat's delivered to us, we all have, you know, everything should be in compliance.
Yeah.
I mean, if somebody brings their own winch and their own tension member now.
But I mean, like calibration procedures for the winches and the LTI 90Is, I don't even, or whatever we're using for that. Yeah.
I understand if you get outside of 3% of whatever factor you have to recalibrate.
I mean, I don't see where we go anywhere that low as far as when we're working, you know, doing CTDs. That's usually always a factor of close to 5.
Right. Nancy Foster got shut down from ROV operations because paid out enough cable to exceed their safety factor of 5. Had to come back in and had to haul back in and refigure everything, I guess.
Oh, really?
Yep. I mean, cable weight is part of the weight of the tension.
Yeah.
You know, you don't think about it. You're like, oh, ROV operation, hell, don't weigh anything in water. But you go somewhere, you go to the Marianas Trench, and now you're all of a sudden got all your cable out. Now you're working with 10,000 pounds of cable.
Or a clump weight or something, a clump weight or a cage.
Right. But I'm just saying now all of a sudden the cable weight is 2/3 of the weight you got out. So,
yeah.
Stuff like that.
Where were they at when they were doing that? Do you know that's how they were?
I don't remember. CI projects or something. I remember telling her about it. She had questions.
Yeah.
Yeah, I think like C-State and Mountain Cable they had out tension spiking higher than what you say workload of 5.
Yeah. I mean, I don't know what they follow. They probably have their own rules, you know, being it's NOAA versus they don't follow the research vessel safety standards. That's, you know, the academic research fleet. It's kind of different, but I mean, it probably should be close to the same. But yeah, anytime we go out, we have a lot of cable out. We need to, you know, calculate things and check things and see, you know, what everything weighs. We can start training our techs to start monitoring it or starting to get used to just dealing with it. I know we haven't done it.
So all that's going to be recorded. So, I mean,
yeah.
Be able to look and see what on that CTD cast, what the max tension, or whatever cast you're doing, what the max tension was, and, you know, act accordingly there. Make sure you stay within that, or if not, if you go
right.
Put in place whatever safety factors there are.
Yeah. I mean, there's an example of the Sally Rides OHS Operator's Manual, the CTDs, although it's been redacted. I don't know if that means not to use it, but it's a good example of what we probably need. But it's like 38 freaking pages. But I mean, this is kind of like some of the stuff that OSU should be working on with their techs or somebody over there in-house. And no offense, but this is probably the downside of not having scripts or who we operate one of these vessels, because they have, you know, personnel to do all this full time. You know what I mean?
Right. Reason the budget is $30,000 a day, I guess.
Yeah.
All right. I'll
Something
get
that an ETO can do.
maybe. I'll get time sheets in.
I ain't worried about it. Time
Tuesday,
sheets due?
Wednesday.
Yeah.
Yeah, I'll work on that while I'm sitting in on this.
I just want, I don't know if our techs are looking at are on this call, but I'd like them to at least be on the list to get, like, you know, they can, whatever they hear is better than hearing nothing of what they have now. They can start training this. And as soon as Donna gets in, I'm gonna get on her about contacting that guy about make sure we're out for bid. We're getting close, should be going out for bid now this week. I know the fucking state's been closed, but we can get the boat over here and get with, you know, some guys and start working on stuff.
Right. Yeah, well, I mean, we can certainly move the boat around the first part next week.
Yeah, let's look at the high tides before we think about doing that too. So
Understood. All right.
All right. Well, I'm just working on my proposal today and listening to this thing.
All right. Well, I'm going to sit in on this. I'll get time sheets in today, and I'll get we'll work on that. Layla's out of town until Friday, so maybe work on that proposal, or that 26 budget a little bit while watching a game or something.
Yeah.
Turn the heat on this boat. It's cold in here.
Do you want me to type that? If you want to type in that question, go ahead and type it in when you get to the computer or something watching this thing. Or do you want me to type it in now?
Type in now. I haven't got my computer set up yet. I was talking to you on the phone. Damn, I brought my coffee from the truck.
It's not one of those questions where you're like, damn, you should know that, Joe. That's why I don't want to ask it.
No, I'm happy to have it.
Let me read Appendix. Let me go to UNO's website and get Appendix A and B up, the current one.
Hey, Sam. Yeah, you can't go back to the slides. I was going to say, if you go back to the slides, like, I wasn't looking at the slides because I was driving. I was just listening to them talk.
Yeah.
But that's what it sounded like to me. You used approve in one. And like I said, it might have just been a slip up. It might have just missed.
Yeah.
It sounded like you said anything under, you have to be certified. Okay. I mean, I assume we now just have a certification process that you do. All right. Let me get a cup of coffee and
all right.
back on this, get this call set up. I'll be texting with you because I have my phone free once I get my computer.
Okay.
All right.
Just I don't know, is your tech watching it? Does you want to watch it? I don't know.
She does. Aware of it.
I guess I can look at the distance and see if it's on there. Okay, no problem.
All right.
All right, bye.
information about that wire or cable, you can put in a PDF format and send it up to the database, and it'll be tracked there. And then you don't have to keep your own log. It's going to be right there. It's really a great way of doing it. It's a service that the wire pool does. I'm sure Rick will reinforce it along the way too. But use the database. You'll learn more about the database later on it. The logbooks required record keeping includes the wire break testing, cutbacks, spooling operations, lubrication, wire train description, maximum payout for each cast, the maximum load for each cast by calculation or monitoring. These are the minimum requirements. Anything else you have for history on that cable or wire rope is going to be a benefit to enter into that database. That way, if somebody else gets to use that cable and wire rope in the future, or part of it, know which section to select, and they know what the potential limitations are on that. So if you have things, additional information, such as any diameter changes and so forth, or corrosion, those are good to put in there too. As you move cables around the fleet, you want to, the receiving person wants to have some confidence that they're going to get what was sort of advertised to them. So if you don't have information, particularly for those in storage, it won't be a benefit to the next person along the way, and somebody might have to scramble to go find a second one. Running use log. Basically, this tracks what you have when you do a deployment. This is an example from the Kuliak from a number of years ago. This looks like a pretty nice one. I use this one also because it was typed, or at least in a database, so it shows up well on the screen. It also has something that now is required, but wasn't before, is it identifies the location where the max tension occurred. Over time, that may be a location where you want to look at that particular part, that has to be cut back or not. So that's a new requirement, and this looks like a pretty good form of the running use log. But we have improvements in the works. Rick has drafted up a new format to try and offer as a standard format, or at least a preferred format in the fleet available to you. And hopefully over the next day or so, if there's any improvements on that you see, we'll get together and we'll talk about it. Maybe by the end of tomorrow, we'll get something really pretty nice. It does refer to positions on the cable, like for max tension, where does it occur from the drum end rather than from the payload end. Because as you do cutbacks, trying to retrack that through history means a lot of calculations. If you record each one from the drum end, then that max tension point stays the same, and it's good history. So suggestions, Rick, I'll be happy to talk to, but Rick will be interested, and his team will be interested in trying to do something so it looks relatively standard. Number of them are handwritten, presently, different formats. Sample wire description. Doesn't have to be too extensive. This is the first one I received. It was for the barns, and they had a pretty small team on the barns at the time. So they didn't spend a whole lot of time developing this, but this is a pretty good wire description. It shows the number of shivs and rollers, and it identifies them and provides the information as to the diameters and the width. And in terms of this one, barns, because it had old equipment on board, was operating a factor of safety 5. They still provided the wire diagram for the 322. So this is very helpful when looking at the situation for the cables afterwards. If you want to do testing, which you do want to do, because you're using UNOL's cables, and there's information you need to do to provide to the wire pool when you do a test, these are the types of things that they're looking for. Good things to record right on their database, because then it's there. So they're ready to do the testing. The identifier, the manufacturer and model of the winch. records of all the spoolings, basically cutbacks, reterminations, anything you've done to the wire and cable. The description, as we just talked about a moment ago. Number of shivs between winch and the water. The D and W for each of the shivs, and also for rollers. Number and duration of deployments, it's the last brake test. Maximum tension during each deployment. Wire out at time of max tension, and that, looking for the improvement aspect, would be the wire in at max from the drum end, would be a better way of doing it. And the max wire out for each deployment, which could maybe we think about doing it from the drum end. So this concept of an improved, preferred set of information would be worked on the next 24 hours or so. If you think about retiring a tension member, at least for steel, there's more criteria for the synthetic. We'll learn about that next hour. If the tension member does not meet the future scientific mission, it's a good one to start with, because that's what you were doing. Peak tension on the shivs at any time exceeds the elastic limit. If the cable or wire rope stretched, or appears to stretch, or the diameter gets thinner, which is probably an indicator of a stretch, at least could be corrosion. Also, if the ABL deteriorates below 50%, I'd get really concerned well before the 50%. But that's what the criteria in Appendix A is. If I saw the ABL starting to decrease more than a few percent, I would get concerned whether that cable still meets your needs, or we have to do a major cutback or switch. Types of damage: kinks, bird caging, abrasion, broken wires, excessive erosion. So any type of damage you can see visually is a good reason to think about whether you have to cut it back or get it replaced. Unlike synthetics, you can't really take out a piece and put it. Synthetics has the advantage you can potentially put them back together. In steel, pretty much when you have a problem, that problem has to be removed, along with the wire at one end or the other. A couple things that you'll see in Appendix A, but they really are applied by the UNOL's wire maintenance policy, one of which is lubrication. We'll talk about that in the program later. It really increases the lifespan of the cable. You'll see, like on cranes, they always lubricate a lot, usually, all the wires on the cranes. And those cables, those wire ropes can stay there for a long time. So lubrication is very important, using, of course, environmental acceptable lubricants. We'll learn more about that. Here's some pictures from Chris a few years ago showing me some of the lubrication systems we'll talk about later. Freshwater wash. Also very important. Keep that salt out of the wire rope and cable. Recommended or required end of every cruise and less than a month if possible. It's referenced again in the wire maintenance policy. And I like to see, where possible, but doesn't required, an automated system, which as soon as you start haul back, would start spraying or freshwater wash. I was very impressed when I went. The first one I saw these was on the Walton Smith, and that cable, wire rope, both the wire rope and the cable, looked very good from one inspection to another. I was very impressed with it for an area which was high in salt, of course, being warm, and in general, for every 10-degree increase in temperature, you double the rate of corrosion. As a general rule of corrosion, from real rough one. So being in the warm area in Miami, I was not expecting to see the cable look as good for so long. But in their systems, this was just part of a picture. And for their systems, as soon as they start haul back, the fresh water sprays. If you're low on water content, you don't have to, of course, have the valve on that does that. But it's recommended. I also have seen manual systems. This one was kind of unique. 2 ropes. This was do it from below neck deck down, but open and close. I don't remember who it was, which ship it was, but it could be a manual system, and it works, provided you work it. If you never turn it on, it doesn't do much good. That was another thing I observed on the inspections is, a ship that was very proud of its freshwater water system, went on the next inspection, it had been forgotten about. So it's good to see it operated. You can wash the drum, you can wash the top block, you can wash, a number of different places between, of course, the ocean and your drum. So keep in mind. Another thing that's not necessarily required, but commented on in Appendix A, motion comp or heave comp, depending which you want to call it. It can reduce your peak loads. It also reduces the zero load factor or snap, which could be tied to snapback. So you can operate typically a little bit deeper if you're watching your tensions, potentially, or a little bit higher sea state if you have motion comp. But it's not a load limiting device in the appendices. Another one of these load balancing aspects is, this was on the Pelican, was a spring damper system. It helped to reduce some of the peak loading at the high end and low end. So if you're interested in that type of thing, talk to the Pelican and see how they like it. Load limiting devices, weak links. The general concept of the weak link is it's set to break below the required brake strength. So you put it on at your payload, and if your payload gets caught on the bottom, then you lose the payload potentially, but you bring back the cable, and you haven't damaged the vessel, put the stability of the vessel in jeopardy, and you have the cable back. In some cases, like for doing a bottom drag, then you can put multiple weak links in it so that it trips and breaks it free and releases the load, but still brings it back up to the surface. So you don't lose anything except your sample that you might have had something attached to the bottom. Weak links are important, and they should be used rather than forgotten about. Scientists tend not to like them sometimes because, I might lose my payload. Well, it's better than losing all the cable and not being able to do the next one because you don't have the cable or the weak link, or you have another problem. The Scripps concept of the weak link, which we see around the fleet, is basically for a bolt that would shear as it gets to a certain tension, and various locations. There's Ross, he's got a design with 3 of them in there. And you can have different strengths of your bolts. So you can create a situation to have various amounts of load required for the weak link on the same weak link system. When you see these in the fleet, there are other concepts. Miami has a shackle that has the pin cut down. Another one where you've used a short section of lighter cable. But it's a good thing to have, saving your overboard handling system. And overall, your cable or wire rope, no matter which it is, should part, or your weak link should part, before anything else breaks. You don't want your A-frame going down over the side. You want the cable to break, and this gives you a control as to where it breaks. Render, basically a fish line. For those who have fished, you get to a certain amount of tension, it drags out, pulls out, and it releases some wire or cable until it gets down to a tension that the drag is set at. There is also render recover, which I've not seen in the fleet, but it might be out there, is where it automatically brings back to its starting point as soon as that tension decreases. But render is very powerful, and it's And it's really good if your problem in terms of it might not be at the bottom or not where your weak link is. So you've entangled in the propeller. On the way down, your weak link wouldn't be there. Nice to have that render. Not that you want to go have anything entangled in the propeller. We've updated the assist sheets. We'll make them available. We've added the synthetic aspect to it, so that's now included. I would say it's increased in size, but not increased in complexity, because much of the synthetic part of the Appendix A assist sheet is synthetic. It's repeated, a lot of it, similar to the steel and wire rope part. Always open to suggestions on how to improve that. And in terms of the inspections going to the ship, we ask that a self-assessment be conducted prior to us going on board to see how you feel that you're doing on the Appendix A, and likewise the Appendix B assist sheet that was developed by Aaron. And then we kind of get a chance to spot check a little bit, a few things. If you have a situation where you're close to meeting or can't meet a criteria or A or B or any other aspect of the RVSS, there's an opportunity to do waivers. You're better off, in my opinion, not operating out of requirements. If you can't operate within the requirement, and I'll use the example of roller diameters as one of the first ones, is if you can't operate within the requirements of Appendix A or B, then it's better off to go ahead and have the safety committee look at that with you effectively by doing a waiver request than to be just operating out of compliance. Because, you know, well, I think it's better overall to do that. We'll hear more about the waivers. The first waiver I was exposed to was from the Endeavor. And in this case, the roller diameters, to get to the 15-inch requirement, that means the winch would run into their operating station. And it's eventually a problem. And they really would have to either move the winch or change the deck configuration for a few inches of the roller, which did not have much wrap angle. So a waiver was given for increase in roller diameter, but not all the way up to the 15-inch. So if you look at your compliance situation and say, well, I can't meet it, but what are my options? Getting the safety committee involved is going to be a good thing. And we'll hear more about that tomorrow. With that, what I'd like to do is, here it is open up for questions. And I know a lot of the questions are going to revolve around wire pool. So Rick, if you'll join me. You're on your own. That's not what you said down at RE Tech. What questions do we have?
If the wire is torque balanced.
Pardon?
Wire is torque balanced.
Yeah.
Does it matter when it's after safety? They say it's torque balanced. We've done there are very well, we took
Wait a second.
and had a wait.
Okay.
Oh,
online one.
online. And so we had a weight down at the bottom, and that weight just spun and spun. Now there are requirements for torque balance. Honestly, those torque balance requirements were determined for U.S. Steel, and U.S. Steel made the 3x19 torque balance wire rope, and it's gone from manufacturer, same, I guess, companies, but different people of operating now, and now it's Wireco. And I have my doubts as to whether it is as good as what U.S. Steel manufactured. So they say it's torque balanced. It is kind of torque balanced, but not completely torque balanced. More questions? You must have a lot of questions. No, Hannah. Anyone but Hannah.
Oh, thank you. I'd be curious to what extent the fleet is lubricating their entire 9/16 wire annually.
Everybody, every ship in the fleet, every ship in the fleet is lubricating their wire, probably less than, no, not they don't. No. Lubricating, and I'll tell you this, you know, when I have to talk, but maintaining their wire, a 12-month minimum requirement is woefully inadequate. That was just to get something down on paper. Doing it every 12 months is damn near useless. It ought to be done, in my opinion, much more frequently. Talk about that a little bit later, but to highlight that is that maybe we need a better way of doing it. And I would really like to see and encourage some vessels to doing it at sea. You don't have to take it off the ship. You don't have to put it back on the ship, lubricate it. It's a 2-day, maybe 2.5-day operation, expensive, costly. Why not do it another way? I can't find anybody who's going to raise their hand. Maybe there's somebody here who raised their hand that says they want to do it at sea, experimentally. No, we did a test. Barbara, I should say we. When I say we, I always, just get used to this, I always mean my excellent team that I work with. We did a test where we took wire samples and we dunked them in the water daily. So we had 2 sets. One set we dunked in the water daily. And, well, we dunked everything daily, but one set we lubricated monthly, and one set we lubricated annually. So we did this for 36 months, 3 years, and what we saw was that the stuff that we lubricated monthly lasted, and the stuff we lubricated annually, they both tracked each other pretty well for the first year, year and a half. But after that, stuff that we did monthly performed much better, and it actually extended the life of that cable about a year. So that was like 30% longer than the one that we terminated, or the one that we lubricated annually. There's a real benefit to doing it. Everybody says there's a benefit to doing it. We ought to be doing it more often, and I tried to push this a little bit, and I was told to back off a little bit because, understandably, all the marine techs are busy doing other things. So when you think about this cost savings, you might lose equipment if you don't do it. People could get injured. I mean, there's lots of advantages for doing it. I really would encourage people to do it more often.
Side-by-side test where you wash the wire, leaving it salty.
No, this is how we did it. Put it in the water, pulled it out, coiled it up, hung it on the wall, outside. When we lubricated it, we lubricated it as it came out of the water. Simulate doing it at sea. So we ran it right through the lubricator. Barbara ran it right through the lubricator and put it on the wall. So it was exposed to the elements outside. We ran it right through, so the seawater was still entrained, you know, imagine. And, you know, it was in my opinion, it wasn't as, I didn't think the results were as good as I hoped, but there was definitely, you could see the difference between the two. I actually have the results. I printed them out this morning because I thought it might be interesting. Tomorrow afternoon, we have a lubrication demo and how to all the equipment set up. I'm going to wind some wire and lubricate it, and maybe the subject will come up again.
Some ships use the brush-on technique as they haul back also.
Winches that aren't used, well, one thing about that, you're taking all my, everything I'm talking about. One thing, you're gonna hear this again then, because once I start, I just keep talking. We recommend rotating the drum periodically. All those contaminants will end up at the bottom of the drum, salts and things. In that case, where it's not used, recommend rotating. Well, I'm not a big fan of body where the wire passes through.
I don't know how much good it did, but the Antarctic program covers their winch drums during their off season.
Yes, hello, can you hear me?
Yes.
Hello? Okay, I was just wondering whatever happened to the wire lubricator that was supposed to be distributed. We had happily volunteered for one, but we've never seen any or heard anything about it.
I don't have any information, but we'll keep our ears open if we get back to you if we can hear something about it.
Okay.
What were you
Thank you.
promised, Max? Max, come back.
Yes, well,
What were you?
we weren't promised anything. There was an initiative, I believe it was from Rick, that said, hey, we'd like to, we have these wire lubricators that we'd like to introduce to the fleet to encourage, you know, more consistent lubrication. And you were looking for volunteers that would try one out. And we volunteered. We're still volunteering.
Would you volunteer to do it at sea?
Absolutely, we do it by hand at sea all the time.
Okay, so you don't have a core lube body through which the wire can pass and get the lubricant applied?
Correct.
All right, I think we need to look into that. Write that down. We got it written down, Max.
All right, that's awesome. Thank you, guys.
Ross?
I'm sorry to say I don't have any thoughts. But, I mean, always open to something that would work, you know, appropriately for the environment that you're working in. I have no experience with it. I can't talk about it at all. I think that's a good idea. Chris, have you had any experience with air curtain, air lubricant, you know, anything like that? Is there any concern from the ship's point of view about availability of compressed air? Would that be a limiting factor for any of the ships? Yeah. I just wonder, anyone here, since we have a lot of crew, is that an issue for the people that are, or the vessels that are represented here? I'm not seeing any hands. Brian?
I've seen them use the compressed air for cleaning the wire on other ships. I was on the James. But it works very, very well. We have a series of compressed, they have a series of nozzles aimed at the wire inside an enclosure, just like you would with water potentially. And I've seen them use that for years, and their wire looks fabulous. It really works well, but it's noisy and takes a lot of compressed air, especially for like a 2.5-hour recovery of a CTD.
So they don't slow down, they don't need to slow down or anything?
No, they turn it on once they start up, and they leave it running until it's on deck.
interesting.
One comment we had during the break in talking to Brian is the concept of training for winches that are brought on board from the winch pools. So some more will be covered later on that in terms of thoughts, but I think something more has to be put in the appendix or RVSS along the way. Brian, you handed you the microphone.
Well, just my initial thought was that these Appendix A and Appendix B are set up mainly for the vessels. You have a winch that's with the ship that stays there for years at a time, a reel of wire that's on board that winch for years. So you have something right in front of you that you can keep track of easily. You know the history, you're with it all the time. And you have the ship's operators who are using those winches day in and day out. They're familiar with them. In our case, we're sending it out with a new person every month. And we're reaching out to Rick to get whatever strength member that scientist requires for his portable system. So training becomes an issue where somebody in Alaska wants to use a winch from the East Coast pool. Flying them out is not prudent as far as, or not cheap. Nobody has time to do it. What we've done in the past is we've worked with many of the scientists one-on-one in our shops. We've had their techs with us to work with them as well. That's ideal. That doesn't happen most of the time. We have our operator's manual that goes with the winch. That's often what most of the ship operators see and what most of the scientists use. We have actually produced some videos with Josh Eaton pointing to, talking about, showing how the goes intas and the goes outas. But training is tricky where we're dealing with hundreds of users, not just the ship crew utilizing a winch. It becomes a lot more complicated, a lot more record intense. So my hope is that maybe we can adapt Appendix A and B to have a B.1 to deal with portable systems that aren't on the ships all the time, with different people using them on a regular basis.
Would you be a contact for the people to contact you for ideas on how to establish that?
Sure, and I won't volunteer Aaron without his permission, but.
And we have several masters in here, and whatever happens on a ship has to be compatible with the master's requirements for safety and so forth. So the masters, if you are thinking about it, chat with Brian if you have some thoughts on the wire pull winches coming aboard, or potentially any winches coming aboard from scientific parties. You may hopefully get the whatever comes for requirements to be compatible between the two. So thank you, Brian, for volunteering. Was another question?
Yeah, no, I just wanted to ask a quick question going back to lubricating at sea, particularly with 3x19 9/16. What is an appropriate dead end weight to have on that to maintain an appropriate spool tension if you're spooling off upwards of 9,000 meters of cable to make sure it comes back on appropriately tensioned?
Chris, would you have?
You just have to talk.
I don't have, wire is in the water, then I think as long as it's not a critical CTD, and it wouldn't be on 9/16, that, if it's an anchor or a pig weight of some kind, you can haul back and lubricate it just the same.
I think there's also some additional information in the winch and wire handbook, but my memory's not clear on that.
I wanted to bring up, recently, last summer, I lubricated 322 on the Atlantis with Prelube 19, and I used about the lower part of that cable was previously lubed with OLLD2 from Grignard, and until I got to about 4,500 meters, the wire was well lubed, but at that point, I started using Prelube 19 on the remainder of it. I checked with Grignard in advance, see if the two lubes were compatible, and was told that they would be. So I just wanted to let people know that that can be done. I'm gonna start changing over to Prelube 19 because according to Grignard, they feel that the frequency that most of our ships, most of the people in our industry are able to do lubrication, because we don't do it at sea all the time, it's that Prelube 19 would be a better option going forward. And I did buy a new pump and new hoses from Core Lube Equipment, but I was able to utilize the same housing and the same brushes that I already had from using it with OLLD2.
There's a question.
Thanks, Chris.
Yes.
I was envisioning it being part of a rehaul. So if you looked at your planned deployments and you had a really deep one, that might be the one you pick so that you lubricate most of the cable that you're recovering. And someone may choose to just do a dedicated deployment for lubrication. I suppose that's fine too. Maybe if there's an issue with lubricant where it's being applied and bringing the CTD up through lubricant that might be on the surface, that might be an issue. I don't know, but I was envisioning as a rehaul and lubricated at that time. So I had a question for you. Does anyone see a problem with including in their wire log, having the reference point being the core of the winch drum, so that you're looking at wire that's remaining on the vessel, what I like to refer to as wire in, as opposed to wire out. Does anyone see a problem with that? Right. And how often do you end for end? Right. And I think my point is that I don't think there are a lot of people that are end for ending. Ross?
You have to plan for it into a maintenance period or something, spill everything off the drum, right? Make sure you're calibrated with your metering wheels and everything, and then draw in, and then you're good to go. But I think, making the transition, you have to consciously make that, and it's an effort for each winch.
Yeah.
Yeah.
I agree.
Most of the vessels probably have a pretty good inventory at this stage of what wire is on drums. It may be inaccurate, but it's probably because, but if you use the same beginning point, it'll be consistent.
I've also been an operator of the winches, and something I would be concerned about of tracking that is how and is it displayed to the operator. So is the operator making note of that number, or is it done somehow automatically? Obviously, making sure that there's no confusion of pay in, pay out, utilizing that number. So at what point is it recorded and how is it recorded? So as an operator, that's what my concern would be.
Valid. And I think the point is that it would be in addition to what you're normally used to. You'd see wire out, but you'd be recording as part of the log wire in. So it's not necessarily anything that the winch operator would see. It's a useful number in terms of the tension member and where issues occur. So if an issue occurs at 500 meters, maybe you had a high tension event or you're watching a particular area, then as you get to that point, 500 meters out, 9,500 meters in, as soon as the cable becomes less than 9,500 meters, that problem area has probably gone away. That's the thought behind using wire in versus wire out. Right now, all we see is wire out, but wire in in terms of the condition of the wire, events that happen to the wire, that would be a valuable parameter for us.
The prescribed, recommended, or however you want to voice it, Rick's thought in terms of it has both wire out and also wire remaining on drum. He calls it wire in.
So I envision it more of a computation rather than something that's up in front of you while you're operating the winch.
You have a question from Lance online.
Hey, Lance.
Hello, can you guys hear me?
Yep, can hear you fine.
Yeah, so my question is on lubrication still. As what we have done in Hawaii primarily is that opportunistic lubrication where we'll do it sometimes on the deepest cast, even if it's not the last cast, or sometimes we'll do it on a deep cast and the last cast, time and lubrication availability. But what I really haven't seen us do a lot of is an end for end lubrication where we actually spool the whole thing off the ship and lubricate it on the way back in or something. So if we're lubricating at sea, just working in the wire out lengths that we're deploying gear, would you still have a requirement to lubricate end for end annually if we're doing it sort of in that opportunistic at sea way? But we're not lubricating the whole thing. It's just however much we've got out at a given time. Does that make sense, my question?
Yes. Yep, that makes sense. I think the way I would envision it, but I'm not the one making these decisions, is more the safety committee that has to weigh in on this, since this is an Appendix A point, is that ships that are making an effort to lubricate at sea are doing it more often than once a year. I would think that that would be an acceptable approach. Now, given what Chris mentioned a minute ago about how he got to a point where he didn't see, or the lubricant was good up to a point, just doing the at-sea stuff where it's going in and out would be beneficial. Now, the other thing I want to just clarify in my own mind here, when I say, or when a cable is end for ended, I'm talking about it comes off the ship and then gets wound onto another reel and then put back on the ship, so that what was the working end is now at the core of the drum, and what was at the core of the drum is at the working end, as opposed to what I think Lance was referring to, where the cable currently, and this is the way a lot of ships are doing it now, the cable comes off onto a drum, and then it's lubricated when it gets put back onto the ship. The working end before is the same as it is after.
Yeah, that's correct. That's what I was referring to.
Just so everyone knows, there's 38 people online, and they're having a hard time hearing. So if you're going to ask a question, I'll just bring the microphone to you.
I think also it's which cable you're working. You know, 322 is our bread and butter. We use it for everything. We're pretty comfortable spilling 10,000 meters of 322 onto a storage drum and pulling it back under tension and lubricating it. And we tend to do that because we get a lot of pushback from science if we're setting up our lubricator on a CTD haulback. But something like 9/16 or 680, if you have 10 grand of that, that's significant weight, and then the haulback to get that to lay down is significant as well. But since we do spill all our 322 off periodically, when we bring it back on, they're slushing the lower core as well as lubricating it, and we'll work that cable, and you'll get down deeper than you've been for an entire year. There's still lubricant on there. So I think that if you're lubricating your deepest haulback, if you can set up for it, you're pretty well maintained down in the core if everything is well lubricated. But the idea of spilling a lot of 9/16 at sea is pretty intimidating too. You know, we all know how well it spools, so you got to have some confidence there too.
Good point. The OLLD2, which many ships have been using, the Grignard OLLD2, was developed with the intent that it would be used every 3 or 4 deployments. It was to be used frequently, and the fact that we're only lubricating once every 12 months. That's why Grignard came back to us and said, pre-lube 19 might be a better option for you. So that's why there's been some shift to pre-lube 19.
Yes.
Certain operations like multi-core dredges are prone to having, I don't want to call them kinks, but bends or slight dog legs towards the termination where the memory is bent, 15, 20 degrees. And I'm wondering if we have brake test data that shows if there's a significant decrease in braking strength when that happens.
Are you from URI?
Scripps.
Scripps, okay. Because the reason I ask, who are the folks from URI? There we go. Okay. We have gotten wire samples back from URI. Correct me if I'm wrong now, Barbara. That they have dog legs in them. They've been, I'm not sure to what degree they've been kinked, but we've done brake tests on those, and they come back pretty good. The results are not bad. It's not as bad as you would think. It's still above the manufacturer's minimum braking strength, so it doesn't really, affect the. Having said that, though, if it's very close to the end, why chance it? I would recommend it get lopped off and re-terminate. But you asked about test results. We do have some. We don't see a big difference in the braking strength because of those dog legs.
Yeah, that's good to know. The thinking that I have too is that if you're right at termination, that's the part of the wire that sees the least amount of tension, right? You have more tension as you get more paid out. And our policy is also to re-terminate it. It's not going to get any better, just re-terminate it, right? But then, if you're doing science op after science op, it's a time consideration too.
Right. One of the requirements for sending in wire samples now is that one end is terminated on one end by the vessel, at least one end, and the other end can be also terminated, or it can be left bare. If it's left bare, we'll terminate it on our end and break the sample. This isn't really anything that I have to talk about today, but my recommendation would be if that breaks low, and we often see that termination pull out, or we have a problem with that termination, that the vessel applied. We go to great lengths to make sure that the termination we apply will hold. So we have the capability to sandblast we can really prep our samples well. And when we break them, many times, fortunately, the break is either a mid-span break or it's at the vessel applied termination. So when it's at the vessel applied termination, it's often below the manufacturer's minimum braking strength. So if you want to operate at that manufacturer's minimum braking strength, you want the assigned braking load to be the highest value possible, we will break another sample. But it saves time if you send us either a longer sample so that we can get the first piece done and then have a second piece available so that we can do that second piece that we terminate on both ends. The reason I can justify that is we learn two things. You learn about your termination, but then when we have that second sample that we terminate both ends, that's the piece that's going to be, well, that's better sample for looking at the total load where that wire is going over the head sheave. And so you get an idea about the actual strength of the cable or wire rope. So it serves both purposes. It just reduces the amount of time that goes back and forth between us where, well, your sample broke low, send us another sample, submit another brake test. If you send us a long sample, we'll do both if we run into poor results with the first sample.
Your termination probably is your weak link in many cases, and you'd like to have a handle on what that value is for the weak link so you don't lose your payload too early. So that's a second advantage of sending in the termination the way you do it so he can test it.
The challenge I see in keeping track from drum end to highest tension spot is those cutbacks and keeping track of those cutbacks, especially when it's a non-taped wire rope, right? And is the technician just doing a new termination, cutting off some random number of meters, and then that whole idea of keeping track of that number kind of gets screwed up.
As long as you're recording what you cut back, working from the winch drum end, we never lose track of where certain events are. But you have to log those cutbacks. And those cutbacks, the database, which Andrea will talk about this afternoon, has the provisions for providing information about cutbacks, lubrication, all of those events. You can just include that information in your database, then you can keep track of it. One place where it all resides. Everything get messed up by a couple of people.
Yeah, Rick, oh boy, I've had some pushback about the added terminations. So that would be 3 terminations that the board techs would need to be doing, say on 3.2. And if it's 681, we don't have endless fittings to mechanically an additional termination on 681. So I wanted you to comment on that, and if there is a policy change, it would be possibly easier for some to digest out at sea if they had a full letter noting these changes. And one, the cutback of the junk wire, and then where you would plan to terminate, cut an additional section off, and then for testing, terminated on both ends, and then their final termination. Is there anything that you written up by the UNOS wire pool to that, so that we don't blindside them?
If I understand your concern, the safety committee approved a revision to Appendix A that said that the samples are to be terminated that come into that are sent into the wire pool. One end is to be terminated by the vessel. So the reference I think you might be referring to would be the Appendix A and the revision or the revised version that was noted June 2023.
Okay.
That's where it says that this has to be the case. That was the decision. Now, on your first point, the sample that we sent, the sample that we ask for is the sample closest to the new working end. So if you have, if you're going to cut back 100 meters, you'd lose the 100 meters, and then you would take your next piece, the next section would be probably the one closest to the new working end. So send us 10, 15 meters of that end. So I see the need to apply a termination to that test sample based on the revisions to Appendix A. Then you would also need to apply a termination to the new working end. So that's, I see the need to put on two terminations, one of which is required in order to use the cable. So I'm not sure I see where the three terminations are needed. The sample would have one, the new working end would have the second.
You put on one wire.
We would put on one of our own on the, we would cut the necessary length, that 5 meters or whatever, and put it a wire pool termination on that end. And then we would then have a piece that had no terminations on it. So if the sample with the vessel terminated end broke above the manufacturer's minimum breaking strength, we're done. Mm-hmm. The termination worked and the cable held up. If, however, there was a problem with the break, say it was a mid-span break, then there's a problem with the wire. The other possibility is that the wire pulls out of the termination applied by the vessel, in which case we would let you know that that termination was the problem area, but we would still break the second sample with terminations that we applied, and we would break that so that you know what the strength of the wire is, regardless of the termination. I feel that my personal feeling is that that gives you the most information. You know about your termination and you know about the cable.
Rick, is there a benefit of sending the part or the termination end that you've been using for whatever number of deployments before you cut it off to you for evaluation?
I'm not too anxious to do that because that's the old working end. We want to know the purpose of the test. I mean, it's interesting, granted. If we had endless amount of time and people, we might want to do that. But the real crux of it is to determine what's the new working end strength and what's the cable strength.
Yeah, I just had a question back to the rates of failure of the ship-applied terminations. Do you see any difference between the Porge socket 322-680 and the 3x19 mechanical plug? Do they fail similarly lower, or is one fail less than the other?
Before I point to Barbara, because she would be able to answer this, she can think about an answer. But as I mentioned, we go to great lengths to terminate these cables in our best manner possible. And that means we have the capability to sandblast these ends, clean them, degrease them, do all of this stuff that the vessel may not be able to do. And so it's understandable that we might be able to get better results. But
sure, I was just wondering if the field applied lent itself to one or the other having more.
Well, I think we see it in both. We're right, but what vessels are using mechanical terminations on a lot of the 9/16 wire that comes in is terminated with Nicopress, with hard eyes. What's that, Ross?
Oh, we use electroline plug fitting.
But as we get samples in from you with those terminations, we will be able to start to accumulate some data about that. Barbara?
So that is something.
That is something that I'm very interested in speaking with you about in the next 2 days, particularly this afternoon, because we're doing, back at our shop, we're going to have a terminating demonstration, but we also have all of our terminations that we use set up, but in types of wire as well. But I'd like to know what you're using, because I don't get a lot of mechanical terminations, I think because you don't want to give them up, which I understand. We would definitely be sending them back to you as soon as possible. We get a sample in, we try to turn that over in 2 weeks. So we would be sending that back to you, whether it was the birdcage 322 termination or a mechanical termination. So we would definitely be diligent about that. But going back to the mechanical, I'd just like to hear from you later. Who's using it? What are you using it most on? That kind of thing.
Yeah, I guess I'd just say, a pivot on Chris Greiner's comment. My concern, or maybe our concern, I think the idea of sending a ship applied termination to you guys is awesome, but it's how long it's out of service. And some of these fittings, if it is a mechanical fitting, they're a couple $100 a piece. So sometimes more. I guess just getting some support from our ABMs or our managers at NSF to increase our inventories of some of that gear so that we can have a third of it lost out of stock at a time. I'd say that's the only real drawback for being really remote.
Right.
There's a question from Lance online.
Hi, I just wanted to ask about, so for 681 cable especially, there's, I would say, not a super standard termination that's used more often than others on our ship, where for some applications we might use a PMI Evergrip. For other applications, we might use a PMI guide grip. We might use, or like the Jason ROV team uses an Electroline sort of termination with the 3 cones and needs to be tensioned to fully seat. So I guess, like my question would be, which one do we choose to send to you for 681? Like, if we're using 3 different terminations with relative equal frequency, which one would we send exactly?
Well, I think that choice is yours. And over the course of 3 years, if you send us a different one each year, we can get across the whole gamut. Or if you want to send us more than one sample with, say, two different terminations, we'll break that as well. We try to be as accommodating as possible. I'm volunteering Barbara's time, as you see.
All right, it's 11:05 right now, so why don't we come back at 11:15 and we'll go over synthetic tension numbers.
Okay. We had one more question from Kristen.
Thank you. This is going back to what Ted was saying earlier with the change for the App A from June 2023, going and using the same shib for the 9/16 as well as the 681. Can you speak a little bit more to that? So that's for the traction winch for the shells itself as well as sheaths. Is that correct?
That's my understanding, and we can look at it more off. But my understanding is it applies to both shivs.
Okay.
And on in blocks.
This was testing that was done at Tension Member Technology.
Okay.
And we looked at the nominal breaking strength of the tension member. We put it around a 48-inch shiv and broke it, and there was no difference in its braking strength. We put it on a smaller shiv, we saw a slight reduction. That was a 48-inch shiv designed for 681. So the 9/16 wire was on a 48-inch shiv designed for 681. And, pardon me, we broke it, and there was no significant decrease in its braking strength. So that testing was what pushed us along to eliminate a lot of the waivers that we were getting and made included it in the revision of Appendix A.
Okay. And this is kind of follow-up question, but it might be in your next presentation. But for the 5/8 synthetic, could you use that same groove, the larger one for the 681?
Well, the recommendation by the synthetic manufacturers is at least 10% greater than the diameter of the, and I can't do it in my head, but wherever, at least 10%. So they're a little more, the groove diameter is a little bit greater than typically for wire rope.
Okay. Thank you.
Thank you. Good time to break. Be back at, you'll be ready in 10 minutes.
That is it.
All right, you guys, it's time. We'll go ahead and get started if everybody can take their seats.
All right, folks, we're going to get started. I'm going to get started. Oh, we're going to get it today. Not too much, no. But I think we're going to, I can feel it. Okay, we're going to start, and they'll filter in, I hope. So what I'm going to talk about is synthetic tension members. The provisions within Appendix A were added, or for synthetics, were added in June. So this is relatively new information, and I'll be interested in your input. I just can't hear myself think here. Let these folks get in. So a lot of what I'm going to say, we've kind of talked about already. You've heard some definitions, but I want to go over a few of these things just to reinforce them so that we're all starting out on the same level. You may have heard some of these things. I just want to make sure, since factors of safety and D over D are important in this discussion, I want to make sure everybody understands. Let's see here. Okay, so there's going to be a few definitions. I'm going to talk a little bit about how wire rope has influenced the use of synthetics. And we'll touch on, I've got a slide on how other institutions are using their synthetics, particularly what factors of safety they're using. And then we'll get into Appendix A and how to get the most out of our synthetics, what are the testing requirements, this ought to be a real hot issue, and what to look for during visual inspections. So, really important understanding of factor of safety. So if you read the definition in Appendix A, it says the maximum stress of material can withstand divided by the maximum stress planned during use. For our application, we're talking about tension members. It's the breaking strength divided by the estimated load of the tension member during its use. So, example, 9/16 wire. You've got a coring operation with an anticipated full-out load of 20,000 pounds. The breaking strength of 3x19 9/16 wire is 32,500. Divided by the expected load, 20,000 pounds, the factor of safety would be 1.6. Is that clear? We're all okay with that? Good. Another definition, we're going to see this a lot, D over D, you're probably very familiar with this. Ted went over it. The root diameter of the sheave divided by the diameter of the tension member. The root diameter or tread diameter shown here in the diagram of the cross-cut vision here. So this dimension here, that is the root diameter divided by the diameter of the tension member. This turns out to be a pretty important variable. And you'll see why in an example that I've got from the Armstrong. And talked about this, sheave groove dimensions. These are particularly important for wire rope. A little bit, I'm not so much, I don't know exactly what their impact is with synthetics, but we'll touch on it. So early on, I forget what year it was, we did some testing at Tension Member Technology. And they did a series of cyclic bend over sheave tests. And if you're not familiar with that, you have two sheaves of a certain size, two samples, one sample here, one sample here, and those and you apply tension. One's fixed, and one you apply tension, and that sample goes back and forth around those sheaves. And we did this test. It was wire. The factor of safety was 2.5. Now remember, with all of these are wire rope sizes. With all of these wire rope sizes, we can go as low as a factor of safety of 1.5. So 2.5 is, I don't know if anybody uses, thinks about their 3x19 wire for the factor of safety 2.5. But it can get down as low as 1.5. We're allowed to do that with Appendix A. And the D over D for the test sheaves was 30. It was just what was picked back in 2008, whatever we did this test. These were the results. These are the bend cycles to failure. And when I look at those, I think they're pretty low. 5,000 cycles, and it failed. And we're looking at a factor of safety of 2.5. They'd be a lot lower if we were working at a factor of safety of 1.5. So I thought this was, when I pulled this up, kind of preparing for this, I thought, wow, those things are low. We're talking about 4,000, 5,000 cycles? Unbelievable. Well, how is it that this wire is not breaking left and right in the field? So this poor plot here, the vertical axis here is rope life, relative rope life, and here we've got D over D ratio. So at a factor with a D over D of 30 shown here, the relative rope service life is a number like 25. It's all relative, so it doesn't mean anything. It's unitless. When we increase that to a factor of safety of 40, D over D of 40, we can bump this up 66% to relative service life goes from 25 to 40. So that's like 66% increase in the rope service life. Now, for 3/8, that's not huge. For 3/8 wire, it means you're going from a diameter of like 11.25 to 15. So we gain significantly in that life. Now, we're still talking wire now. Appendix A, as Ted said, the selection of a sheave is either 40D or 400D1. 40D, where D is the diameter of the wire, or 400 times D1. D1 for wire rope is the largest diameter of the outer wires. So it turns out for wire rope, the 400 D1 gives you a larger diameter. And so that's what's used in Appendix A. So in the case of 1/4 inch, 3/8, a D over D, or the diameter of the shiv is 12 inches or 18 inches for 3/8, so forth. The D over D then works out to be like 48. So now we're really working up on this part of the curve. So we've actually, by going from some number like 30 to some number like just under 60, it's doubled the service life. So that's one thing to our advantage, because we're using larger shivs, larger D over D. The other impact here is the groove diameter. All of these things, you may think, what the hell is he talking about? We're supposed to be talking about synthetics. All of these things apply to synthetics as well as wire rope. And the groove diameter, we operate, for wire rope, we operate in this range here, 1.025 to 1.1. So this axis here is the shiv groove diameter divided by the rope diameter. So how much larger is the shiv groove compared with the wire rope? And the vertical axis, again, rope length. So we work in this range here typically with wire rope. And it's rope life here, 100, it's all relative, 100%. So we're up in the high end. So again, groove diameter does matter. To get used to the clicker hicker. Okay, so for wire rope, I don't know about you, but I pay more attention to the factor of safety and the anticipated loading. I don't really give much thought to what has that wire rope seen already. Maybe we should be paying attention to what it's been seeing, because it can only do so many cycles over that shiv. But historically, our experience has been that it's not a concern. Hasn't been a concern. Maybe it should be. But maybe, you know, a lot of wire ropes are replaced not because they fail, but because they get too short, or the condition of the wire rope itself is poor and we get low breaking strength. And that may be contributed by the number of cycles that it has seen. But we don't have, excuse me, a lot of it is with wire rope is that corrosion. The wire looks crappy, and the mandrel wrap is low, the E-kink that we do is low, or is high rather, mandrel wrap is high. So we say, we think you better change out your wire. It's not because it parted. Now synthetics, on the other hand, we don't have very much experience, very little experience. And every time that rope passes over a shiv, there's an incremental piece of damage that occurs. So we don't have the corrosion. So there might be a temptation to continue to use that synthetic while it looks good, or relatively good. And that's why visual inspection is also very important with synthetics. So that damage that occurs every time that shiv, every time that rope, synthetic rope goes over that shiv, a little bit of damage. And it's accumulative. It accumulates from cruise to cruise, from deployment to deployment, and cruise to cruise. So the question is, how much damage has accumulated from its previous use? And how much is too much? That's why we need to have a good record of how these synthetics are being used. We need good use logs, and you have to conduct good visual inspection of these tension members. Okay, if we disregard the environmental influences, you know, UV, the way it's handled, you rough handle it, you're running it across a deck that's, you know, has no skid on it. The rope life is dependent on three things: shiv diameter, the number of shivs that are used to overboard it, and the loading. So, as you can see, I go backwards here. It doesn't seem to, here we go. Okay, so shiv diameter, that's where the D over D comes into it. The loading, that's where the factor of safety comes into it. That's why we need to be familiar with these terms. So what's everybody else doing in the community? Well, in the Netherlands, they're running with a factor of safety of 5 with their synthetics. In Germany, it's between around 4. In Norway, around 4. Foss Maritime, check with those guys, they run around 4 to 5. So everybody except for the Brits are using their synthetic tension members with a factor of safety of 4 or 5. The Brits, on the other hand, are able to operate as low as a factor of safety 2 because Lloyd's have given them a dispensation because of their line monitoring systems. Well, we have line monitoring systems too. So we should be able to make use of that information. Okay, so according to Appendix A, the way it's written now, you have to use it with a factor of safety of 5 and a D over D equal to 40. And along with some other provisions that are mentioned in table 8.5. So, but with some tension member history, with some details of proposed operations that are coming up, knowing the configuration of the shivs, knowing the configuration of the overboarding system, we can work with the manufacturer and try to drive that factor of safety down so that it may be possible that certain science applications can take place. However, all of that stuff in this bottom section here, it takes a lot of time. We can't wait to a week before the cruise to make this determination. If there isn't sufficient time, you're going to be stuck with a factor of safety of 5.0. So let's take an example. Neil Armstrong, RV Neil Armstrong cruise. It's a coring cruise. It's going to take place in the Puerto Rico Trench. Water depth is 8,000 plus. Core head, the barrel and the couplers, the trigger core and the arm weigh 7,500 pounds. The anticipated pullout for the cores is somewhere between 7,500 and 10,000 pounds, just to get it extracted out of the bottom. So our total loads are around 15,000 pounds. 9/16 wire for this application, 8,000 plus meters. The wire alone would be about 12,000 pounds. Add to that the 15,000 pounds anticipated load, so we're up to 27,000 pounds. We can't use 9/16 wire rope, which breaks 32.5 below a factor of 1.5. Wire rope is out. That size, 9/16 wire. And we're limited because that's what the ship had. Now, can we do it with a factor of safety of 5? No, because all we could get with using 9/16. So the idea is let's use 9/16 diameter plasma line, and we have it. It breaks at 37.9. The advantage is that it's nearly buoyant, so it's neutral. And so we don't have to worry about the weight of it in the water. And if we had to work with a factor of safety 5, if we waited to the last minute and they said, hey, let's use this plasma, they'd be limited to 7,580 pounds. Not going to happen with that. So, but they approached us. We worked with them and the manufacturer. And the manufacturer started talking a language that I was not familiar with. He's talking about life factor. And they defined the life factor as the product of the D over D and the factor of safety. So that's where the shiv size comes into it and the anticipated load. Now the manufacturer has got a whole database, apparently, for different life factors and how long the rope will last. Now, granted, these are all laboratory tests, nice environment, steady loads. All of that has to be considered when we're thinking about this. So, little exercise here. The So the Neil Armstrong with their 9/16 plasma HICO line predicted piston pullout 15,000 pounds. So the loading expressed as a factor of safety, braking strength of the 9/16 plasma is 37.9. The anticipated load was 15,000. So we're looking at a factor of safety of 2.5. The D over D, oh crap. See, every time I push this damn thing. Oh, I'm probably putting it the wrong way. Sorry, folks. Here we go. So the D over D, because we're using a winch that normally has 681 on it, it's 48 inches. And so the D over D is going to be pretty big. And it comes in at 85. So the life factor for this application, for this specific application, Armstrong, D over D of what we have, this particular wire or rope, the life factor is 215. Now, based on the manufacturers, they went back and they looked at their stuff. You know, it's all proprietary. You can't get a lot of this information from them. They give you little snippets. But they said that that rope's going to fail after 165,000 cycles. That sounds pretty good. So their little chart here, they gave me a little bit of data, which I plotted here. So in this, we have a life factor on the horizontal axis, and we have on the vertical axis cycles to failure. These are the data points that they provided, and for 215, we got about 166,000 cycles to failure. Okay. Now, Neil Armstrong, that's the number of cycles to failure if you had one shiv. But in order to overboard this cable, you actually have more than that. You have 4 shifts. So you get a quarter of the life. So now you're down to about 40,000 cycles. It still sounds pretty good. If you want to ask about traction heads, they only considered the first shiv on the drive. They didn't consider the other ones. That was their call. So that's why we dropped down to about 40,000 plus or minus operations to failure. So the pre-cruise determination for this exercise said, we think you can do it. You can run with a factor of safety of 2.5. I think that's safe with the number of operations that you plan, which was around 100 cores or so, with that D over D of 85, with this rope, and the number of shivs that you've got in line. And it'll probably be okay if those tensions get up to the point of being on the high end, you know, the 17,000 pounds, where we dip down to a factor of safety of 2. But they didn't want us operating at a factor of safety 2 all the time. The limits were 2.5, okay to drop down lower once or twice, a few times, it's going to be all right. Post-cruise, they had a good log. This was the OSU coring group. They had a good log of what transpired, the number of actual deployments, maximum rope deployed for each, max load for each operation. And in addition to that, the manufacturer was very good. We sent them samples, and we'll talk about where those samples are taken for evaluation. They wanted to do a visual inspection, and they wanted to do a brake test. So after the inspection, they found little to no levels of internal abrasion, a bit of external abrasion, but the internal abrasion was pretty minimal. They broke all 5 samples, and they were all higher than the minimum braking load. Great. We got 1 data point. Not like wire rope, where we got people using it all the time. We got 1 data point. So in order to go through this process, what do we need? We need to know how the rope has been used previously. What has it seen before? That's why it's important to continue to keep good logs on these synthetic tension members. If you even drop 1 cruise, we don't have any information about what happened, all of a sudden we don't have that good history, and I'm not sure what the manufacturer is going to say about being able to load this thing up to lower factors of safety. We need to know the number of shivs encountered during the overboarding operation. We need to know the tread diameter of all the shivs that are going to be encountered, the groove diameters, and then the science requirements. What are the dry and wet weights of the gear that's going to be deployed, the weights of the samples that are collected, and what are the anticipated static loads during the proposed operation. So we need all that information, and with that information, and importantly the history of that tension member, we can then go to the manufacturer and work with the manufacturer to try to meet the needs of the science with that particular tension member. It may not be possible. I mean, you gotta be prepared for the answers, no, we don't think it's a good idea, but we're willing to work with them to try to drive that factor of safety down so that you can do the science that's necessary. Testing. All right, this is gonna be a real issue here. We want to get samples before and after its use. All right, that seems pretty straightforward. The reason, and we have to jump into this at some point, but if the sample prior to its next use can be taken from the working end. That's easy, the working end, because we don't know necessarily how is it stored, was it exposed to any contaminants. We want to have a reference point that when we start this cruise, we know that at least that working end of the sample was in good shape. So that's why we want to get a sample from the working end prior to the cruise. Following the cruise, though, here's where it gets a little more complicated. So at the conclusion, the sample from the working end is not representative of the rope's condition. The sample from a section, we need to get a sample from a section that's gone around all the shivs while under load. Sample location and length will vary from ship to ship, and you know your ships, but I'm going to show you where the best place for these samples to be taken. It provides us with a post-use condition. It also gives us a heads up whether this rope ought to be retired at that point or whether it has some life into it, so that we don't find this out at the last minute or when we start to think about that next operation. And all of this information contributes to what degree the use affected rope life. So what do we have left in it? So for the post-cruise synthetic sample, we want to taking a sample down here. This piece of rope probably hasn't seen any of the shivs. This piece here has only seen one shiv, and so forth. We need to go all the way back, so somewhere between the drum, the storage drum, and the first shiv. Now, this piece of rope has seen all the shivs, and we know that every shiv contributes to the incremental and accumulative damage that occurs. So that could be, that could be 100 feet, 200 feet. We may have to cut back to get that sample. The pre-cruise sample, that's the one that can be taken from the working end. That's fine, getting it right there at the working end. That sample should be terminated on both ends. There should be 2 meters of uninterrupted or uninvolved rope between the splicing that takes place on either end. And then we don't want it too long, and that's why the wording here is total length should not exceed what's needed for the end terminations plus 2 meter clear span. If it gets too long, we're not going to be able to fit it in the machine. And now we got to consider about stretch too. So that's why we're trying to keep these sample limits that are mentioned in Appendix A. Now this is all part of the synthetic section in Appendix A. So Ted talked about this a bit. The log should include the identifier, the NSF tension member identifier, the number duration of deployment since the last brake test, max tension of each deployment, line out at the time of max tension, max payout for each deployment, and a description of the ship train used to overboard the synthetic. These items here, although they can be included in the log, these are things that can be recorded in the database as part of its history. And Andrea will talk about that this afternoon. So you've seen this before. I threw in a little picture here. This is URI, the Endeavor. Nice picture of the sheave train. It includes dimensions on the sheaves, the number of sheaves, and so forth. It has the identifier information, and then all the same columns that Ted showed a little bit earlier. Okay, what are we looking for? The other important part is looking at the tension member itself. So we got a braking strength, but we also want to look at it and evaluate its condition. Abrasion. What's the condition of the external abrasion? What's the condition of the internal abrasion? Open that rope up a little bit, you know, in the case of this plasma rope, 12-strand rope, you can scrunch it down and you can look inside, see what kind of abrasion's going on in there. In this case, this picture here has a minimal internal abrasion, a little bit of, oh crap. Is it going back? No, it's going the right direction. So a little bit of external abrasion. You can see little tufts there, but the internal abrasion looks pretty good. This is also a problem. You need to think about this a little bit. Jacketed synthetic cables, you don't see the synthetics. So that, you know, we start to lose that capability to look at what the synthetics are doing with a jacketed synthetic cable. Cuts, here's a particular partial cut through one of the strands. It's going to reduce the strength of the rope. Here's a pull. Usually you can work these back into the rope and get that pull to settle down. Burns, you know, was it on a traction head and the traction head was just spinning so that it heated up and burned the rope, or is it, you know, from friction? All of these things are not good things, obviously. Look at are there any unconformities in the rope, some reduced sections or bloated sections? All of these individual strands need to be working in unison and take up the load together. So that kind of stuff disturbs it. It's actually a point of stress on the rope itself. Contaminants, you know, sandblasting grit or rust can get into the fibers and damage them. Exposure to kind of chemicals, you know, things that you might be using to wash the deck, rust, you know, rust removers, whatever. They can all be contaminants that will affect the strength of the rope. That's why we want to do this brake test before the cruise, after it's been, wherever it's been in storage, where it's been sitting. Discoloration, here's two ropes of the same type. One's been exposed to UV, one hasn't. No, we're not. Interesting to see what the impact of that exposure has on its braking strength. Could be a chemical cause of discoloration as well. Look at the splice itself, the end termination. Is it the appropriate splice for the rope that's being used? Is it the manufacturer's recommended splice? Is the thimble that's in it, there's no thimble there now, but is the thimble in it cocked? Is it in the right orientation? Are the tails of the splice sitting out where they should be and not sucked into the termination? So these are the things we need to look for and be aware of. So the brake test and the visual inspection are important. Both go hand in hand. So Any questions? Yes, sir. That's fine.
And we're buying new. Brian Beverly with the Coast Guard. We're getting new inland buoy tenders, and one of the things we're going for is synthetic line on cranes, cross-deck winches, and all those things. And we're running into an issue of a chicken and egg, where our equipment vendors want to know what rope we want to use, and rope manufacturers want to know what crane it's going to go on. So in this case, it sounds like it's all existing equipment and switching over to synthetic line. Is that the case?
Well, we're backing into it. You know, we've got these winches on the ships. We've got things they want to do. The wire's not working. What can we put on that ship that'll do what science wants? It'll fit on the winch drum, have enough line to fit on the winch drum. The right way to do it is to, what kind of science, or what are we going to do? What's the appropriate tension member to do it safely? And we are now, Ross is involved with this. That's the direction they're going. They're saying, what do we need to do the science? And that's the right way. But we had to get into this somehow and learn a few things. Like I said, we backed into it. They're doing it a better way. We've had good experience, and I think Ross has had some good experience dealing with the folks at Cortland. They're willing to work with us. They'll sit down when we have an application, and they'll work with us, let us know whether they think we can do what we want to do. Like a lot of our wire and cable are basically our wire is basically from one manufacturer. Our cable's basically from one manufacturer. And you build up a relationship with them, and I'm thinking we do the same with our synthetic right now. And as long as there's a good relationship and things are moving along, I don't see a reason to hop from one to the other based on price or whatever. You have a good engineering system or engineers that are willing to work with you.
And then one other thing, you had some pictures of UV damage stuff.
Yeah.
And this is more mooring line, but it's still synthetic fibers. We're getting a lot of anecdotal evidence that after a year or so, the strengths in synthetic lines that have been exposed to UV and weather and fatigue loading just aren't near what they were originally.
Right.
And we still don't have a good way to quantify that, but.
Well, I have experience with moorings, and I have experience with use of synthetics on moorings. And I can attest to the fact that we will put out a surface mooring, so you're going to see lots of dynamics, surface mooring, for a year, and when we bring it back, there is definitely fatigue, degradation in that synthetic. And it occurs largely where there's a change in the continuity or the change in the say, a rope is pretty supple, but we splice ropes together, and so that splice produces a very small but stiffer section. And so it is creating what I would refer to as like a knuckle. And so that rope is doing this. It's not doing this. It's bending a lot right at those points. And when we break samples at those locations, we get a reduction in the breaking strength of that synthetic. Now, these are nylons, the 8-strand nylons, but I do see exactly what you're talking about after about a year. And we can push them a little bit longer. We can go 18 months, degradation's worse. And wherever you have a point where the rope is bending a lot, and we have this on surface moorings because we transition from one type of rope to another, those are the areas where we see the most degradation.
Thanks.
Sure. Bonnie.
I was wondering if we could talk more about like jacketed versus not jacketed, because we did a cruise recently where I feel like a jacketed cable would have made the wire more resilient to, in this situation, was an issue with the level wind, to the point where we couldn't do the deployments because the cable dragging across itself was just like cutting it in a way where we couldn't use it anymore. And I feel like a jacketed synthetic in that situation would have been like much more rugged.
It may very well be. It's just, and it's not that I'm knocking the jacket, it is limiting in your ability to see what the tension member looks like. With a wire rope, you're looking at with a wire rope or a cable, you're looking at that tension member. With a synthetic like what we saw or what was on the Armstrong, we could look at it, we could see it. But when it's jacketed, you just don't have that visual inspection. And that doesn't mean, there's stuff going on in there. That rope is working, and it's those fibers are moving past each other. So you have to be cognizant of the fact that there is stuff happening that you just don't see. But there may be many other pluses to using that jacketed.
Alex Wick from OSU is online and has a question.
Yeah, hey, everybody hear me okay, I assume?
Yep.
I've got a couple of questions and comments for you. I guess first of all, I only get one, fair enough. Make it a good one.
Make it a good one.
I work for the Ocean Observatories Initiative, and we've been using synthetics for 10 years, overboarding large moorings. And we have a pretty extensive record of the sheep train pull test results from various manufacturers. I'm not sure how much I can talk about the various manufacturers, but the one the fleet is using right now is the best one by far. And so if you're looking for more data, I have a ton of stuff that I can give you. I guess one question I had is in the for the factor of safety of 5, it's recommended that the D to D is 40. Where did that come from? Because everything that after discussing with the manufacturer, Cortland, they're saying diminishing results in longevity of rope after D to D of 30. So I'm just wondering where the 40 came from.
Sure, good question. Part of that 40 came from us backing into using synthetics with existing equipment. And the thought is that we know that higher D over Ds do benefit us. We know that many vessels currently have shivs that are at least 40 D. And so the thought was that we could possibly do more with what equipment we currently have with a 40 D over D. So it was a little bit of what's out there in the field, and I'm not sure if we would have been able to do, say, the Armstrong cruise with a D over D of less than what they had, and that was because they were using pretty large shivs.
Sure, that makes sense. But for the synthetics, you need the groove to be 10% over the diameter of the wire. So don't you need to, I guess, just re-groove all those blocks anyways if you switch to synthetic?
Yeah, you're right. We need at least 10% on the groove, and there may be some shivs that aren't going to work well with synthetics that we currently have. That's true. We needed to start somewhere. I don't see this revision to Appendix A as the end all, but we had 3 new vessels coming online. We have the need for putting something down in Appendix A that gave ship operators some guidance on how to use synthetics. That was the impetus that pushed us to have something in there. And so we had to start somewhere, but I don't see it as being, I see this being a living document that will, as we gain more experience, will be adjusted accordingly.
Got it. Yeah, I'm not trying to put you on the spot here. I understand we need some place to start with the synthetics here in the fleet. My other question for you, can we do poll tests here on the West Coast? I've been poll testing stuff here through a private place rather than sending them your way. Do you want them all sent to you, or can we just poll test them here on the West Coast?
Well, I would love to see the results, and the advantage to sending them to us is that it doesn't cost you anything except the shipping, and we get to see the ropes themselves rather than just some break test result. And I can't remember what the status of this is, but the Appendix A used to say that you could get the results and send them to us, but I'm not sure if that, I know that they recommend having it done by the wire pool, and I'm not entirely sure, without going back and combing over the words, whether having it done outside is still an option or not. But some break test is better than no break test. We would prefer you send them to us.
Okay, got it. And my last 2 comments, and then I'll stop taking up everybody's time here. What we've discovered is the splice really matters on these, the 12 strand stuff. Double taper is super important. And then to the comment somebody made about jacketed cable or rope on our air tuggers, we switched over to using Maxi Braid, which is a Yale product, and it's jacketed, and it's made our air tugger lines last 4 or 5 cruises now compared to 1 cruise prior. I know this is pretty specific for air tuggers being drug across the deck and whatnot, but yeah, it was better. And if anybody has any more questions about various synthetics, I'm open to answer them. I guess you can get my contact information through Megan. Yeah, thanks for your time.
Yeah, the air tugger lines certainly do take a lot of cross deck, dragging them across the deck. So they do. I can see where a jacketed line might benefit or be beneficial to that external abrasion that can happen with air tugger lines. Aaron.
Online, we have a question from Jay-Z. That's letter J, letter D.
Can you hear me?
Yes, can hear you.
Yeah, it's John Zan from Ocean Exploration Trust. I was just thinking about your earlier slides where you used life factor to predict 165 cycles to failure for a lower factor of safety. For that works well for coring operations. I'm thinking more where our peak tensions are going to be wave induced. Is there a way to, is it okay to operate at a lower than 5 factor of safety where your tensions are going to be cyclical and you're going to get, 500 cycles per hour?
That would be a question that I would pose as part of the inquiry as to whether you could operate below a factor of safety of 5. That would be a question I'd be posing to the manufacturer. Give them as much information as we have, describe what the operation is and so forth, and see what they came back with. I do not know the answer to your question. And bear in mind that factor of safety 2.5 was okay for the very specific Armstrong cruise. It's not okay for everybody to use every synthetic to 2.5. It's really going to stress the fact we got to pull in the manufacturer to talk about what you're going to be doing and get their input on it. Particularly if it's one of their products. We can't be asking them to evaluate Yale's product. They'll probably tell us it won't work. That's all. Got to be lunchtime yet. Yes.
There's been talk about like different vendors. There's been talk about different vendors for synthetics. At Scripps, we mostly use Samson rope. I've heard Yale here. Is there a recommendation of just longevity and quality of product?
I don't have enough information to say that one product is better than another. My thoughts on dealing with one manufacturer is if you can engage them in their engineering and they can give you good information, then okay. But it's really, my decision to pursue Cortland was more based on the response that I initially got when I expressed inquiry to these manufacturers. And Cortland came back with the most, response. And were willing to work with us. And not only did they talk the talk, but they walked the walk. They actually did what they said they were going to do and worked with us. That's the only reason why I'm pointing to one manufacturer.
That at OOI, we've seen lower pull test results from Samson. So I started to steer away from Samson because a lot of their brand new pull test results were below what they stated was the minimum brake strength. If you want to know more, you can email me.
Thank you.
And Max Kramer has a question online as well.
Yes, regarding visual inspection, I've experienced over the decades quite a wide variety between different inspectors of synthetics. Oh, that cable is just fine. There's nothing wrong with it. To a fairly brand new cable being deemed damaged. Are there any more more objective standards for inspecting synthetic members? I don't know, magnification, microscopes, what have you. Could you comment on that?
Max, I don't have any more. I can't add to that. Just don't have that experience. I'm all out of information now. I'm just completely, you've sucked it all out of me. I didn't have much to begin with, but.
Yeah, no problem. Thank you.
Okay, good. I think lunch is here. Hoping lunch is here.
Online, Jay-Z, did you have another question?
Oh, sorry, I guess I forgot to lower my hand. So I do not.
All right, thank you very much. I think lunch is arriving, but I'm not sure what the status of that is. Anything else you want to talk about? Any questions for Ted?
I had a process question. I kind of backed into the synthetics process this year, and I think I learned by my mistakes. But so I requested, there was a science party bringing a winch on board, and I requested that they do a brake test before they came on board, which they did, and then they provided me the results with. But I didn't realize that I was wondering what is the preferred process for that, because I think some steps were missed in it in terms of like sort of what you would like to see.
Me personally, no.
It seemed that way.
Well, I think the wording in Appendix A says that I wasn't prepared for all this, but, if a third party, correct, now, Aaron, you can speak up here. If a third party is bringing a winch on or bringing a tension member on, it has to be tested prior to the cruise. And I think the hope is that that happens early on in the cruise planning process. Anything you want to add to that?
I agree.
You're a lot of help.
Rick,
When somebody shows up with an untested piece of gear, like the day that we're, loading the ship, then they don't leave us with a whole lot of options.
What do you do?
Yeah, there's no equipment history. So it puts us in a really hard position. We have to tell the people, no, you can't do it, or.
But you've got, what we have now in Appendix A is something that says that.
Yeah.
That is a requirement.
Yeah, at Scripps, we're in a unique position that we have the winch pool at the same place the ships are being loaded. So if there's an emergency, oftentimes we can use a winch pool winch if we have to, but that's not always the case. So, yeah, in having a discussion about what gear is allowable and not allowable and what expectations are very early in the game, that's key.
Particularly if it's a winch. I mean, structurally, is it appropriate? Appendix B and all that other stuff we'll hear about tomorrow.
Yeah, and it speaks really to the planning process as well, because the strength member Hannah had, it's crossed some of your decks, it's crossed my deck, and we found out all just hanging out, talking over a beer, the stuff's 10 years old, had a splice in it from 6 years ago nobody knew about. The scientist is showing up with this, saying, that's my winch, drum it up, let's go. And so, giving the marine tech some teeth on the deck, some way to push back. We tested it. That was awesome, but 10 years of history on that stuff's lost.
a couple items on that. Almost all operators have in their planning processes that I've seen a timeline where they have to notify earlier. The other part, there is teeth in Appendix B that if it hasn't been tested, you don't have to take it on board. So
yeah, that's a lot of stress when Chief Spy is breathing down your.
But make sure you get early. Question for Rick. The extenuating circumstance plan. I gave several examples of situations. Are there any specifics you can think of relative to synthetics that should be thought about?
Put me on the spot. I'll give that some thought.
Sounds good.
Okay, Lance online has a question.
Hello. This is kind of a repeat question from something I may have asked at RV Tech, and I'm just still not very sure of what to do here. So with synthetics, we've got a science party that sails with us quite often, once a month or once every other month. And they do a lot of free floating arrays that are made up of what we call, individual lengths of shot, which is like 100 meters of synthetic with various, butterfly knot or alpine butterfly knots on it, or other bits of knot work or splice work to put science experiments on. And they reuse these various bits of line quite often. And so I guess I don't know how to approach this, the testing requirements for that group or any group like them that is going to bring 6, gallon trash bin size things of line, or, a couple 100 meters of line for various bits of arrays. If they've got them spliced on both ends and there's even different manufacturers, I'm just looking for some guidance and some ideas, I guess, on how how we might work in Appendix A for a group like that.
Yeah, tomorrow we're going to discuss, we're going to cover that to some extent. It turns out that the situation you're describing, where you have a streamer, it looks like a tension member on an overboard handling system, but it's really the instrument that's being deployed. It's the thing we're deploying, and it's not part of the overboard handling system. So actually, in that case, Appendix A and Appendix B don't apply to that particular line. So when we would test it and how, I think it's kind of up to the chief scientist, and they're the ones that are putting their project on the line if they're not doing it properly, I guess.
Was that enough guidance?
That's very helpful information. Thank you.
Nice. Get some helpful information.
There are no more questions online.
Okay, I think we're going to be around for a whole nother day, so if there's other questions, we can be around. Thank you. Yes, sir.
I think it's reasonable. What was the operation going on in the photo? The CTD being recovered and there was another wire overboard.
I thought that was a great picture.
I thought that was an easy one.
I know, I thought, if I had taken it, maybe I would have known. I wasn't on the trip.
Just curious, that's all.
No, sorry.
All right.